So tonight we're going to talk about special products of binomials. Specifically, it's number 18, the second 18 on your test, and then 19 and 20. Now, you guys have had a lot of practice with these during our current unit, our factoring unit. You've worked with going from expanded form into factored form, specifically with your perfect square trinomials or your difference of perfect squares, so your two terms. So this should be a lot easier of a concept now that you've practiced it so much going the other way around. But let's just remind ourselves of what our rules were when we are going from factored into expanded. So if I have a factored form that is a plus b squared, I know that my expanded form is going to be a squared plus 2ab plus b squared. Now in the current unit that we've been working on, you know to look at a squared plus 2ab plus b squared, see that the first term is a perfect square and the last term is a perfect square, multiply those together and double them to get the middle term. The last unit I was trying to get you to see that when you have two numbers that are in a binomial and squared, I was trying to get you to see that you will always end up with this form. Same thing if I have subtraction. So if I have a minus b squared, what is our form going to be? Remember, it's the same perfect square trinomial, except now our second term is going to be subtraction. And then the last one I wanted you to see was what happened when you had binomials with opposite signs, but they're still perfect squares. A and B are still perfect squares. So that would be like if I had a plus b times a minus b. And in those ones, when we FOIL them out, those middle terms are going to cancel. So I know that my final answer is going to look like a squared minus b squared. So let's work through the problems that were on the test real quick. So I actually wanted you to not show your work on these problems, which I know was crazy to you guys, but I wanted to make sure that you knew the pattern. Hopefully now you know why I was so strict about that, why I wanted you to see the pattern. It's because I wanted you to be able, this unit, to be able to go backwards really easily from expanded into factored without having to go through the whole MDASF process. So if I see something like number 18, which was 2x minus 6y squared, I automatically know that in order to get my answer, I have to square the first sign, square the second sign, and figure out what 2 times 2ab is going to be to get my middle term. So my first term, when I square 2x times 2x is 4x squared. My middle term is going to be 2x times 6y, which is 12xy. And when I double that, I'm going to get 24xy. And I know my sign's going to be negative because this one's a subtraction. And then my last term, I know I just square the last term here. So I have 6y times 6y is 36y squared. So that's my final answer. I know that I took 2x and I squared it. I took 6y and I squared it. And my middle term was 2ab. So 2 times 2x times 6y. Or you could think about it as negative 6y, but you don't have to. You can just think about that second term as being subtraction because it's subtraction. Okay, hopefully that helped a little bit. Let's work through number 19, which is the same thing, except now we have an addition sign. So we have 3s plus 4t to the second power. Same thing, I'm going to take 3s and I'm going to square it. So I have 9s squared. I'm going to take 4t and I'm going to square it. So I have 16t squared. And to find my middle term, I'm going to figure out what 2ab is. So 3s times 4t is 12st. Double that, and again, I'm going to get 24st. And this is my final answer. All right, the last one was when we had those opposite signs in the middle. So we had 9m minus 4p times the quantity of 9m plus 4p. Once I see that I have binomials that are pretty much identical except for their signs, the only thing is I have one addition and one subtraction, I know that my middle terms are going to cancel when I FOIL this out. So all I have to do to find my answer is do 9m times 9m, which is 81m squared, and then I do 4p times 4p, which is 16p squared. And I know there's a subtraction in the middle, because I have to have those last terms, negative and positive, multiplied to be a negative. This is why when we go backwards in our factoring process, you have to have a difference there. You cannot have an addition sign and be finding the sum of two squares. You have to find the difference of two squares. I have 3 sample problems that I want you to do. Oh, sorry, your very, very, very last keyword right here is I want you to spring, because I am so ready for springtime. All right. The last 3 problems for you to do are, let's do 5x minus 7y squared. And please do not show work on these. So you should be able to just go straight from the problem to the answer. Then we have 8m minus 6n times 8m plus 6n. And then I've got, ooh, that's 10. That's a 10. X plus 4y squared. So I want you to pause the video for a moment. I want you to work these out on your own. Come back when you have answers, and let's check our work together. All right, so hopefully you've paused, you've worked them out. You didn't foil, you just saw the pattern, and we're able to go straight to an answer. So on the first one, I see that I've got 5x minus 7y, which means I'm doing 5x minus 7y times 5x minus 7y. And I know that I'm going to end up with a perfect square trinomial. So I'm going to do 5x squared. 5x times 5x is 25x squared. On the end, I'm going to have 7y times 7y, which is 49y squared. I know it's going to be positive, and this one's going to be negative. And then I'm going to do 2ab, which is 5x times 7y, which is 35xy. And then I'm going to double it, and I'm going to get 70xy. So if you can't read that, let me rewrite it so it's not so cramped together. You're going to have, it's 25x squared minus 70xy plus 49, and it's still cramped, y squared. There we go. All right, on the next one, I notice I have the same binomials, but I have one addition and one subtraction. So I know my middle terms are going to cancel out. So I'm going to square the first term. 8m times 8m is 64m squared. Square the last term. 6n times 6n is 36n squared. And I know they're being subtracted. All right. And the last one is that I'm going to, let's see. Sorry, guys. I just got distracted by my child. Okay. Back where I was. So the last one, I have a binomial being squared, and it's positive, so I'm going to take my first term and square it. 10x times 10x is 100x squared. And then I'm going to take my last term, which is 4y times 4y, which is 16y squared. And I know the middle term is going to be 10x times 4y, which is 40xy doubled, which is 80xy. So hopefully we got the same perfect square trinomials and the same difference of perfect squares. If you want to check your work now that you're experts at factoring, you could go backwards and see if when you factor, do you get your factored form. All right, guys, hopefully you are all ready to take your test and come see me on Monday. Bring everything corrected with a parent signature stapled to your original test, and we will let you do a redo. Okay, good week. Hope you have a good weekend.